I built a production Kotlin Multiplatform app. It runs on Android, on iOS, and on desktop from one shared Kotlin codebase, and I built it solo, directing Claude Code as my coding partner, every commit public. This is MyEuroStatApp, an open-source client for the European Union's official statistics office, Eurostat. Not a demo, not a toy dataset sitting in a JSON file somewhere in the repo. Real, live European data, pulled at runtime from Eurostat's own API, rendered as production-grade charts across 8 subject areas. In the next few minutes, I am going to show you the app, show you the architecture underneath it, layer by layer, and then tell you exactly how this got built. The honest version, mistakes included. If that sounds interesting, stick around, because this is also the trailer for the 24-episode series that builds all of it from scratch. Population, economy, trade, transport, environment, tourism, social well-being, science, 8 subject domains, and every single one of them is wired end-to-end to real Eurostat data, not mock screens waiting for a backend that does not exist yet. What you are looking at right now are actual screenshots of a running build. A population pyramid built from 18 age cohorts, a multi-country GDP line chart, a diverging bar chart of intra-EU trade balances, a transport module comparing road and air passengers with a log scale toggle. Pick a country, and every one of these screens updates instantly. This is the overview a user actually gets when they open the app for the first time, not a curated best-case demo reel. Let me be specific about what real data means here, because that phrase gets thrown around loosely. 19 live Eurostat datasets feed this app, GDP in billion euros, population by 5-year cohort, greenhouse gas emissions in megatons of CO2 equivalent, trade flows at risk of poverty rates, R&D spend as a percentage of GDP. All of it fetched from Eurostat's dissemination API at runtime, passed from the JSON Stat 2.0 format and cached locally. None of it is hard-coded. None of it is a screenshot pretending to be a live chart. This project is an independent, unaffiliated third-party client, not built or endorsed by Eurostat, released under the AGPL 3.0 license, with the underlying data itself licensed CC by 40. Look at this population pyramid for a second, because it is a good example of what hand-built actually means in this code base. 18 age cohorts, 5 years each, split left and right into men and women, pulled from the demo IASCAR PJAN group dataset. You can toggle between total, men only and women only, and the pyramid redraws immediately. You can drag the year slider across more than a decade of history, and it never touches the network to do it. The data for every year is already sitting in memory once the chart loads. This is not a charting library's default bar chart repurposed to look like a pyramid. It is a purpose-built shape drawn cell by cell on Compose canvas, specifically for this one demographic visualization. That level of custom work repeats across all 8 modules. Here are the numbers that back up the word production. 20 Gradle modules, roughly 20,000 lines of Kotlin, organized in strict clean architecture, data, domain, UI, repeated consistently across 8 feature modules. 499 unit tests, currently at 0 failures, including a real iOS simulator test job running in continuous integration, not just a compile check. No mock anywhere, because mock does not link on iOS native. Every test double in this project is a handwritten fake that runs identically on the JVM and on Kotlin native. 49 commits on the current development branch alone. A visible incremental history, not a single AI-generated dump. and an active application to the NLNet NGI0 Commons Fund, submitted with a fully candid disclosure of exactly how AI was used to build this. Start at the bottom of the stack. The root settings.gradle.kts includes a composite build called build logic, and every one of the 20 modules is listed explicitly, no wildcard module discovery. Type-safe project accesses are enabled, so referencing another module in a build script is a compile-check property, not a fragile string. All the version numbers live in exactly one file. The Gradle version catalog, Kotlin 2.1.7, Compose Multiplatform 1.7.3, Ktor 3, tweet, SQLDelight 2.3, Daplit Koin Decompose 3.2. 2. The convention plugins inside Build Logic, the Kotlin Multiplatform Library plugin, the Compose plugin, the SQLDelight plugin, mean individual module handout. That consistency is what makes 20 modules maintainable by one person. One layer up is Core Network, and its job is deceptively simple. One shared Ktor HTTP client reused across every feature module rather than recreated per screen, because recreating clients leaks file descriptors on iOS. The engine swaps per platform through Kotlin's expect actual mechanism, OKHTTP on Android, Darwin on iOS. But the call site you see here, fetch dataset, is identical everywhere. It takes a Eurostat dataset code and a map of dimension filters, builds the request using Eurostat's own repeated parameter filter syntax, geo equals PL, geo equals DE, and so on, fetches the raw JSON stat response, and hands it straight to the parser. Every one of the 8 feature modules API services is a thin wrapper around this exact function. This is the pattern I am proudest of, and it is verbatim from economy repository implec.it. The observe function is a flow that follows a strict 5-step protocol. First, emit loading, so the UI shows a shimmer immediately. Second, check the SQLDelight cache. If there is a hit, emit it right away with an isStale flag computed against the 12-hour time to live, and if it is not stale, return immediately with no network call at all. Third, only when the cache is missing or stale does the code reach the network, wrapped in a try-catch. On success, persist the fresh data and emit it. On failure, the catch block checks whether there was ever a cache. If yes, the error is silently swallowed, because the user is already looking at useful content. If no, it emits a real error. That single HUD cache flag is a deliberate UX decision encoded directly in the control flow. Navigation runs on Decompose, not Compose. Navigation and not Voyager. Every screen in this app is a Decompose component context. Default economy component here is the pattern repeated in all 12 feature components. It gets a lifecycle scoped coroutine scope tied to the component's own lifespan, a mutable state flow holding a sealed UI state, and a single on-intent entry point for every user action the screen can produce. The component talks to a use case, the use case talks to the repository, and the repository is the stale while revalidate flow you just saw. 12 of these components, one per feature, plus settings, overview, search, and compare, are wired into one root Decompose children stack inside Compose app. Here is the same economy screen, sameeconomyscreen.hd. Same Kotlin source file, showing Germany on the left and Poland on the right. Switching the active country is a chip tap. There is no network refetch, no loading spinner, no screen transition. The country data for every country you visited in this session is already sitting in the session cache. The UI just re-renders against a different slice of state. That instant switching field is not a special case bolted onto the economy module. It is a property of the shared component architecture, one adaptive two-pane layout, one Eurostat theme design system, one set of composables rendered identically whether the active platform is a phone, a tablet, or an 84D D-score desktop window. Every chart in this app is drawn on raw Compose canvas. Koala Plot, the charting library the project started with, was dropped entirely, and Core Charts now ships 8 distinct chart types: line, stacked bar, the population pyramid, a tourism seasonality heat map, a diverging bar for trade balances, a radar chart for science indicators, small multiplies for transport, and this one multi-line highlighted, which powers the social module. 3% series drawn together: poverty risk, at risk of exclusion, and self-perceived health, with one series visually spotlighted while the other two recede into the background. All 8 chart types share one underlying model: chart point, chart series, chart axis, a shared color palette. So adding a 9th chart type reuses the same primitives instead of starting from zero. Pull back and look at the whole dependency graph. Koin wires every repository as a singleton and injects a dispatcher provider into each one. Production code never touches dispatchers.io directly, which is exactly what makes the whole thing testable with a fake test dispatcher later. SQLDelight owns the cache layer, type SQL, schema version 3, a JSON blob multi-dim cache table with real, numbered migrations rather than a destructive recreate. Decompose owns lifecycle-aware navigation across all 12 feature components, and Compose Multiplatform renders the actual pixels, one design system, one adaptive layout, from a phone screen to an 840 density independent pixel desktop window. For libraries, one coherent architecture, repeated 8 times across every feature module. Here is where it stopped being easy. A single JVM only to sorted set call silently blocked iOS compilation until it was tracked down and removed. A top-level regex using Unicode property class compiled fine and passed every JVM test, then crashed the entire file's initializer the moment it ran on Kotlin Native because Native does not support that regex feature. Invisible on Android, fatal on iOS. Then the Xcode toolchain itself. Xcode select was pointed at bare command line tools instead of full Xcode. Xcode build was exiting with code 72, and the checked-in Xcode project turned out to be a 1.2 kilobyte stub. The fix was a real Xcode generated project, a linker flag for SQLDelight, an info.plist fix, and a corrected Kotlin export name so Koin could actually initialize on iOS. Now, the honest part about how these got built. Claude drafted the scaffolding, the 8 Eurostat API services, the JSON-stat parcel, the repository pattern, the Decompose components, most of the Compose screens, and most of the 499 tests. My rule was every line reviewed, compiled, tested, and frequently rewritten before it ever reached a commit. The test cases for the JSON-stat parcel specifically, I wrote those by hand myself, deliberately, to pressure test the AI-generated parsing logic against edge cases it might not have considered. And twice during release hardening, I had Claude scan the codebase adversarially, not for style, but for real defects. Wrong Eurostat dimension filters, silent catch throwable patterns that swallow bugs along with expected errors and accessibility tab targets that were too small. Here is what all of that architecture buys you. On Android, the APK builds, installs, and runs with an adaptive launcher icon and English, Polish, and Ukrainian strings. On iOS, The app compiles and now actually launches in the iPhone 17 simulator, rendering live Eurostat data on screen, verified with a real Xcode build run, not a compile-only check. On desktop, a self-contained package under 100 megabytes runs on macOS, Linux, and Windows with a single java-jar command with native installers configured for each platform. 3 shipping targets, 1 Kotlin codebase, the same composables, the same repositories, the same stale while revalidate cache. That is the entire point of Kotlin Multiplatform, demonstrated with a real app instead of a hello world. So here is what happens next. Every single layer I just walked you through. The Ktor networking layer, the SQLDelight stale while revalidate cache, Decompose navigation, the hand-built Compose canvas chart library, Koin dependency injection, and yes, the full iOS Kotlin native fight gets its own dedicated full-length build episode. 24 episodes total. Building this exact application from an empty Gradle project to what you just saw on screen, one commit at a time, with the real Git history as the receipt. Nothing is hidden. Nothing is pre-baked between episodes. If you want to actually learn Kotlin Multiplatform by watching a real production build instead of a curated tutorial app, this is that series, and it starts July 21st every Tuesday and Thursday. Every file path I mentioned in this trailer, economy repository in plaid.ect, EuroStatApp client.ect. The economy component, the settings.gradle.ect's module list exists right now, today, in the public repository at github.com/romantisseek/MyEuroStatApp.clone it, run the tests yourself. It is licensed AGPL 3.0 LATower, which means any derivative work has to stay open too. That was a deliberate choice, not a default. You do not have to wait for episode 1 to start exploring. The code is already there, the commit history is already there, and the NLNet funding application with its full AI use disclosure is linked in the description if you want the complete unfiltered story of how this was made. To close the loop on what you saw today, a real app pulling real data from a real government statistics agency, shipping on 3 real platforms, built by one person directing an AI coding assistant in the open with the entire process. Successes and iOS toolchain disasters alike, documented and public. No hidden edits, no cherry-picked commits. Episode 1 lands July 21st, and it starts exactly where a real project starts, an empty Gradle file and a decision about what module comes first. If that is the kind of build log you want to follow, subscribe now, because the notification for episode 1 is the only way you will catch commit number 1 live instead of scrolling back to it later.